Hello, dear students. Today we have Proposition 20 of Book 3. Proposition 20 of Book 3. In a circle, the angle at the center is double the angle at the circumference when the two angles share the same circumference as base. Okay, we're going to have three possibilities. Okay, first let me try to explain the things. This is the angle at the center, and this is the angle at the circumference sharing the same circumference as base. In each one of the situations, you're going to see the sharing circumference be dashed black line, okay? It's going to be very easy. Now look, there's going to be three possibilities. Either the angle at the circumference and the angle at the center share the same diameter, okay? Look, that's a diameter going through the center. This is the center. Or the angle at the center is within. The diameter will go through it, or they don't share the same diameter, and when you connect the 2 points with the diameter, they're not shared, okay? We're going to do this one by one. The only real trick we're going to use from our bag of knowledge is that in any triangle, the exterior angle is equal to the interior and opposite angles, okay? So any triangle, the exterior angle is equal to the interior and opposite angles. And if those angles are equal, this angle will be equal to double one of them. Obviously, if this equals this, and this equals this and this, this equals double this, because double this is this plus this. Not a big deal, okay? So here we have first case. Here's the center. Here's an angle at the circumference, and here's an angle at the center, sharing the same base. That's given. Thus, it is required to show that the angle at the center is double the angle at the circumference, okay? Now, let's look at this here. These are radii of this circle. Therefore, they're equal. Therefore, the angles at the base are equal. Yeah, that's what we're going to use in our bag of knowledge as well. But that's pretty easy by now. Remember, an isosceles triangle, the angles at the base are equal. Okay? So this is an isosceles triangle because these radii are equal to each other. These two sides of the triangle are equal to each other. Therefore, the angles at the base are equal. This equals this. As we said earlier, then therefore this is double this. If this, this is double this, but also you say double this equals this and this. Let's do it that way. Double this equals this plus this. Great, but here in this triangle, here's the base extended. The exterior angle is equal to the interior and opposite angles, this plus this. But this angle plus this angle is equal to double this angle. So this angle here is equal to double this angle, okay? Do that one more time real quick. Isosceles triangle, angles at the base equal. Therefore, this plus this equals double this. But this, being the exterior angle of this triangle, is equal to those same two angles, being opposite and interior angles. Okay, so this is equal to this plus this, but this plus this is double this, so this equals double this angle. This angle, which is the angle at the center, is double this angle, which happens to be the angle at the circumference. Okay? Let's do another case here. Let me use a black one. Here's our circumference again. But this time, when you connect it, it goes through. They're not sharing it as one side. It goes through, okay? So this is we're gonna basically do this twice over here, okay? So here you have, look at this triangle, extending this base. This angle here is mirror this, look at this, is the exterior angle, and these are the interior and opposite angles. Let's do a little bit of dashed line this way, say. Okay? So this angle here is equal to this angle plus this angle. But look at this triangle, these being equal because they're radii of the same circle. So here you have a triangle with two sides being equal, isosceles, therefore the angles at the base are equal. So this equals this, which is to say this plus this angle plus this angle is twice this angle. So this angle being equal to this plus this, and this plus this equals twice this angle equals twice this angle. And then we're going to do the same thing on this side. Let's go in this direction now. This angle, okay, and this triangle is the exterior angle, okay? So therefore it equals to the interior and opposite angles. So it equals this and this, okay? But look at these two angles. They're equal to each other because this is an isosceles triangle, because this and this are radii of this circle, and they're also sides of this triangle, making this triangle an isosceles triangle. Therefore, the angles at the base are equal. This is equal to this, which is to say this angle plus this angle is twice one of the angles. But we showed already that this angle is equal to this angle plus this angle, being an exterior angle of this triangle. Remember this. The exterior angle of any triangle is equal to its opposite interior angles. So this is equal to this angle is equal to this angle plus this angle. But this angle plus this angle is twice this angle. So this angle is equal to twice this angle. But this angle is equal to twice this angle, okay? Therefore, this angle plus this angle are going to be equal to twice this angle and this angle. Which is to say, the angle at the center, sharing the same circumference, is twice the angle at the circumference. Now we have one other possibility, that is when there's nothing in common here, okay? Look at this. They're sharing this. They don't have anything of the center in common. This guy's at the center, but he has nothing to do with the center. Well, let's make a middle term. Let's connect those points. Okay, and then continue. Okay, now we're golden. Okay, so here we're going to have a triangle. I'm going to do this solid to make it look a little better. Okay, here you're going to have a triangle, and these are equal because they're radii of the same center. You see this triangle? Then the extended base. Okay, so let's use blue here, see? So, in this triangle, see this triangle? This is the exterior angle. Here's the triangle, and here's the exterior angle. This is the exterior angle. So, this is equal to this plus this, which is to say, this is equal to double this, just like we proved before. Great. Okay, so this big blue thing is double this big blue, big blue angle is double this big blue angle here. But now, look at this triangle. See, look at this green, black, red triangle. Sides equal, radii are the same, so this is an isosceles triangle. Therefore, the angles at the base are equal. This is equal to this. Therefore, this is double this. But look at this triangle here, the same one. This is the exterior angle of this triangle. Make sure you can see this triangle. Extend this. This is exterior angle. The exterior angle of the triangle is equal to the opposite interior angles added together. But this angle and this angle, being the opposite interior angles, are also the angles at the base of this isosceles triangle. Therefore, they're equal to each other, and therefore together they're double one. So if this is equal to this plus this, but this plus this is double this angle is double this angle. But this whole angle was proven equal to double this whole angle. So let's take equals from equals, or doubles from doubles, say. If this whole thing is double this whole thing, and part is double part, the remainder, that is to say, this red angle, the remainder is double the remainder. Okay? So the big one is double the big one, the part was double the part, therefore the remainder is double the remainder. But the remainder is our angle at the center, having the same circumference at the angle at the circumference. So we just showed then that in this case as well, the angle at the center is double the angle at the circumference. That's a little bit hard, and you could probably do it with matching colors or something that would be nicer, but you'll see. It's also nicely done in the website of Byrne, B-Y-R-N-E, Byrne. Okay? So therefore we have shown that in a circle, the angle at the center is double the angle at the circumference when they share the same circumference as base. Quod erat demonstrandum. Thank you. Bye.